Welcome back. Another week, another episode. This is Jesse. This is HashrateUp. Today I'm speaking to Tyler. He wrote this great book, Bitcoin Mining Heat Reuse, which we are talking all about. And I especially went into the topic of economic viability because I believe that's necessary very much for this type of use case for Bitcoin mining to scale. I hope you enjoy the show. Take something away from it. Leave a like and a follow. You know how it works. Enjoy. All right, we're back. My name is Jesse. I'm here with Tyler Stevens of Exergy. Is that how you pronounce your company, Tyler?
Yes.
Nice. How are you doing?
Doing well. Happy to be here. Thank you for having me on.
Yeah, absolutely. We met each other in Vegas. It's a common trend with guests these days. I met a couple people in Vegas. There were a couple people there. We met at this side event. What was it? The golf tournament.
Yeah,
I showed up a
Sports
bit late.
Network.
Yeah, and then Christian introduced us to each other. But anyway, we'll get into what you do just now. I want to quickly run through the basics here. We are at 901.118 on the block height. Fees are still very low. And on the hash price, we're at 52.69. Not too much change from the recording that I did 2 days ago. And then established difficulty adjustment is now nearly stable, nearly at zero. Before it was going to be a lot easier pretty soon to mine already. And we're like 2% away. So it's imminent and there's not a lot of change coming for miners in the coming hours. Tyler, you wrote a book. This book.
I did.
It's published by Brains. And you wrote this thing. Forward is from Paul Jin Lee, CEO of Fog Hashing. Bitcoin mining, heat reuse. Heat is a product, not a problem. The industry has really talked about heat reuse for a bunch of time already, I feel. But it's never really, and I think that's something you're highlighting in your book as well, never really gotten to a point where it's like, or we're not there yet, I should say, where we are unilaterally only building mines, where we can use the heat. In my opinion, we'll have to get there at some point because you'll have to get paid to mine Bitcoin as the competition increases. But we can get into that just now. Tyler, give my viewers and listeners brief background on yourself, who you are, what you do, why you do it. And then, we can delve into it from there.
Sounds good. Yeah, my name's Tyler Stevens. I used to studied mechanical engineering before I was a Bitcoiner. Moved out west to Colorado, took an aerospace job. Ended up doing thermal engineering, heat transfer, temperature prediction. So I was focused on all things heat, building models around that. And then all the while, met the local Bitcoin community, kept going to Bitcoin meetups, BitDevs. We have a pretty strong group out here out west, and became a Bitcoiner. Over that 2-year time frame, ended up learning about mining a little bit closer to the end, which I think is common for some people. Mining is one of the last things they start to dive into. And with my unique background, I viewed them as electric heaters. They just convert electricity into heat. I'm sure we'll dive into the efficiency and how that process works. And so that's what I viewed them as, very power dense electric heaters. And I kept thinking about, okay, how can you use this heat? And then you go on Twitter, you start diving down Bitcoin Twitter, and you see all these guys that are already integrating it into their furnaces, their homes, their businesses, space heater products. You see some larger heat reuse sites. And so for the better part of a year, I left my aerospace job in January 2024, and I kept my head down, focused really deeply on all these heat reuse projects, really going down this specific hash rate heating rabbit hole, and figured out that it makes sense to compile all that knowledge. And I chat with Christian from Brains. Shout out to Brains. They've done a lot of great work to make educational content. They've got a plethora of books. And I pitched it to him and I said, hey, I think this could be a niche topic. It could be a cool book in their series after their Bitcoin Mining 101 and Bitcoin Mining Economics. And come the end of 2024, and then at the beginning of this year, 2025, we launched the book at Bitcoin Park in Nashville. And now it's out. And so now I'm working on building a company to install and integrate Bitcoin miners as heating infrastructure. I lost your audio for a second.
What are you working with the company at the moment? What's your current status? Like, what are you into? Are you already like working on projects, or are you still busy figuring out the logistics around setting it up all up?
Yeah, I've spent a lot of time going back and forth on what is the best way to do this. And you've seen people and companies like Heatbit, for example, or even Canaan that makes industrial ASICs at the silicon level coming out with home heating products, gadgets, and space heaters, right? And I think that makes sense. It's a product that you can use that chip, that technology for, and use the product. Its byproduct is what it was originally thought of as, the heat being a byproduct. But in these gadgets, the heat is the product, and the Bitcoin is supplemental. But to integrate that into a home, a lot of what's covered in the books is that you kind of have to do some hacking and retrofitting and integration to make a slick solution where people have their water heaters, their furnaces, the thermostat on the wall controls the device. And so there are no polished products that fit that need right now. And I don't think that's what I want to focus on right now, because what I've come to realize is these integrated solutions, there's a few more barriers that I think are interesting to solve, which is, if it's not a gadget, if it's not a space heater, then someone else usually installs it for you. Someone sizes it for you. Someone tells you how much heat you need and plugs it in, and the plumber comes and connects the pipes and all of that stuff. So with Exergy, what we're looking to solve is that the supply chain and distribution network. So we have technicians that understand this technology in a key target market where it makes sense from the economic perspective, which we can talk about in a little bit. And then right now, it's a little bit of, you got to be a guinea pig in the sense that you take an industrial ASIC and it kind of has to be hacked together. You can put it in boxes, small immersion tanks like Fog Hashing wrote the forward, or some other solutions to make it fit your heating needs. And so I guess to summarize, we do two things. We figure out how much heat you need based on your heat demand, where you live, how much money you'll save, how much sats you'll earn. So we'll figure out that. And then we look at the catalog of just what we know internally. This industrial miner is good for this. You can convert this one into an HVAC system. You can convert this one into a water heater pretty easily. You can convert this one into a radiant loop. Maybe it's a small cabin or something. You only need a couple space heaters. And we just give those people a couple options. They're Bitcoiners right now, the people coming to us that are interested in this. And then we point them in the right direction.
It's interesting, right? I mean, I have a PC on my desk standing right next to me, and looking at it, it does exactly the same, right? It takes electricity, the highest quality of energy form out there, and then through computation produces heat, right? And all the heat that my liquid cooler and my fans and the fans on the GPU and everything is outputting is basically that electricity. And then there's some sort of passive heat sinks on there that make sure the heat gets transported off. But really, my computer does the same thing. All of the power that it takes ends up being heat at some point, right? And it's just what happens with that electricity in the middle that matters. Now, ASICs are really special because you can turn them on and off whenever you want without any economic disadvantage. I can't do that with my computer. If we were recording our podcast right now, right, and I don't want to heat my room anymore, I can't just turn it off. I think that's the big difference, right? What other groundwork do we need to lay, Stephen or Tyler, to make sure that the listeners don't drop off as we go into your tier system and the more complex topics?
Yeah, I think you're bringing up a very key point, which is that you can't get rid of energy. Energy cannot be created or destroyed. Without getting too nerdy, it can only be transformed. And so even the gasoline that you use, the petrol to drive your car with a combustion engine, maybe only 30% of that is converted into motion, that kinetic energy that spins the wheels. Most of that comes off as heat. Actually, the way your heating system works in your car is it just pulls heat off the engine, which, side hack, if your car's overheating, turn the heat all the way up, it pulls heat into the cabin and cools your engine down. And so it's all about managing energy. And to your point exactly, that a desktop computer, I was geeking out with a guy here in my office the other day. He just bought a brand new GPU for an AI desktop that he's building, and it's a 600-watt GPU. That's literally more than the space heater in the office next to him. But the difference, what's the difference between that and an ASIC is that GPU is only running when he's running his AI models or playing a game. It's not monetizing that energy. And so for the first time, that's why I view this being the introduction, the invention of smart heat, which is kind of a side invention of Bitcoin, is because you now have an open source, neutral, ethical monetary protocol that anyone can join at any time. You can shut the machine on or off, and it only does this one thing. And by the nature of how it routes that electricity through the circuit boards and being connected to a network that rewards you for work, you really do have smart heat that pays without counterparty risk. I mean, you probably know, like, there were those things you could have joined years ago with your desktop where you can donate your computing power to solve, gene codes or work on, college campus model processing or whatever, and maybe they'd pay you a couple dollars, so you had to connect your bank account. It's the same principle here. You're getting rewarded for your electricity consumption, but heat is a big byproduct. Now we can focus on heat as the product, and no matter what, without any configuration or any company or individual controlling this, it's just a decentralized protocol. It'll pay you for doing so, pay you for turning it on when you get heat.
This episode is sponsored by Hashbranch, the easiest way to mine Bitcoin in the US. Sourcing hardware and rack space usually is a mess. Bad deal structures, misaligned incentives, and no visibility after deployment. I have placed tens of thousands of ASICs in partnership with Hashbranch. What I like most is that they cut through the noise. Fair pricing, aligned terms, and access to hosting that actually works. Use code HashrateUp100, visit hashbranch.com today to get $100 off of each miner that you order. I was, funnily enough, I was talking to like an OG Bitcoin miner who lived in Canada, and they're only often, like in the country where I live, right, South Africa, it gets very, very warm for a lot of the time. And even in winter, it doesn't really get below 5 degrees or Celsius or 10 degrees Celsius, right? And so there's really no need to install a bunch of gas infrastructure like in Europe, right? In Europe, there's a big gas heater in the basement of every house or of flat buildings, and then you've got like radiators with water running through them. The water's being heated up, and the rooms are being heated. Here, that's not the case. Like, no house has this. So it's all gas heaters, or it's all power. It's all electricity, right? Mm-hmm. And in a similar case, somebody was saying, I think they were up in Canada. They were just saying, look, at some point I realized that if I kept my Bitcoin core software running on my desktop and I enabled the mining function, then it would actually just heat my office up. So they would use the desktop that way, right? Or the CPU. Let's talk about the tiers. Tyler, let's talk about those. Anybody that wants to can read the book as well, of course, but that's kind of what I want to focus on, the different use cases that you outline in there. Do you want to lead us through those briefly?
Yeah. So right at the very beginning of the book, chapter 2, I talk about hash rate heating, Bitcoin mining heat reuse, just another term for it, across different scales. So residential is tier 1, industrial and commercial businesses is tier 2, and then large scale, the mega mining operations are tier 3. And I thought it was important to break that down at the beginning of the book because I do view it as two different things. The challenges are different, the CapEx is different, the economics are different. And so we can start with residential. Residential power is expensive. Most people don't want to run a Bitcoin mining operation full time, pay for that electricity bill. What is interesting to them is paying for heat when they were going to pay for it, that sunk cost, and getting a benefit along the way. So that's like a big differentiator for tier 1, which is it's very much not a typical Bitcoin mining operation where you're maximizing uptime and duty cycle. You're trying to match that hash rate, that hashing power, to your heat demand. And so that heating profile, dependent mostly on the weather, because that's what drives people to turn the heat on and off, and their climate drives the heat demand, and how much mining power you need. And so duty cycle is typically lower, for example, unless you're in a very cold climate. Like it's not that high in South Africa. You don't run the heater that often, which makes it hard to get your ROI, if you're thinking that way, on an expensive computer digital heater that mines Bitcoin, right? Shifting to the commercial and industrial application scale, that's where, it might be the case that your heat load is not dependent on the weather. Maybe you're a brewery or a distillery or a greenhouse. And so you're going to pay for heat perhaps throughout the full year. It doesn't matter what it is outside. You need this heat as part of your process to build a product, to perform a service, whatever it may be. And so it shifts a little bit closer to the traditional Bitcoin mining operation. These could be a couple hundred kilowatts, maybe up to maybe a megawatt. I mean, it's a gray area where we call that crossover, but they get the benefit of being able to have higher duty cycles, and so they can monetize the system um, more frequently. And then at the largest scale, the mega mining operations, these are very much Bitcoin mining operations. They're traditional. It looks just like any regular Bitcoin mine. You got all of your big infrastructure, your containers, etc. And what you rely on is having somewhere to send the heat. And so a challenge for them is typically these sites are located where power is cheap. It might be in the middle of nowhere, but it might be the case that you can co-locate that or build a facility next door that's going to be a buyer of large heat demand and have that synergy there where you can sell that heat. But it's almost the inverse of residential, which is you're going to mine all the time and sell the heat when it's convenient, versus on the residential side, you're going to heat when it's convenient and you only get the mining rewards when you're heating. And then, there's some nuances too in the differences in the hardware as well, because we just talked at the beginning about what I was doing with Exergy and trying to hack together industrial miners for the residential applications. The hardware on the market, the vast majority of it right now is for those larger tiers. And so it's actually almost easier the larger scale you go to find solutions, hardware solutions, because it can look like a normal Bitcoin mine. That's not a big problem. They've got a utility room. They've got full-time trained technicians or maintenance guys that are brought up to speed on how to run this operation. It's not a big deal to have a large piece of industrial equipment to use, versus if you have a residential device, heating appliance, heating infrastructure that's in your utility closet. The average person doesn't know how to deal with that if something were to go wrong. The products don't look like water heaters or boilers, things of that nature. So there's some nuances across the board as you go up in scale.
I agree with you. I think tier 3 would be the easiest to implement, especially as there's then also capex available to build out certain things where the specific cost per unit of heat might be lower, but the total volume of capex is higher because you just need to transport a ton more heat off site. Let's start with tier 1, right? So my whole, and I said this to you before the interview, my whole thesis is around this is only going to scale if it makes financial sense. There's hobbyists like me who have a decorative S9 on their shelf in summer, and then they heat their office. But let's be honest, I mean, nobody wants the noise. It doesn't look particularly appealing. It weighs way too much, and there's probably also cheaper ways. Well, maybe not cheaper because these ASICs are fairly cheap, right? But let's say I'm a customer of Exergy and I come to you as a house owner or whatever, and I say, look, help me figure out my heating solution. Do you tell people, look, these are the scenarios in which heating with electricity for you makes sense? And yes, if yes, then what are those? And another question around that is this maybe where we also see used hashboards, old hashboards being repurposed, which also comes at significant cost because somebody has to sit there and take the ASICs off of the hashboards and repurpose them, or do something with the miner to put it into a product. To maybe expand on this a little bit more, and the heat bit looks good. It's not noisy, but it's probably, I don't know how much, but a lot more expensive than a $50 space heater, which might not look as great and futuristic and doesn't have an app. But it does what it's supposed to. It heats up the room. And so how does this scale specifically? Let's talk about that a bit more in detail.
These are all great questions. And specifically with Exergy, I am most focused on bringing Hashrate home, bringing Bitcoin mining back to where it started in the home on cypherpunks computers and laptops and GPUs. So, but as you just outlined, there are a lot of challenges associated with that. To answer the first question, if someone comes to me at Exergy and says, I want to do this, essentially that first step, we call it a heat audit, and that's what's talked about in the book, is mapping out all of the heating economics and the Bitcoin mining economics, the energy economics of the power. And the end result is basically like a go, no go, thumbs up or thumbs down, should you do this or not. And what we've seen from doing a lot of these analyses is there are specific target market specific heating fuels where the economics seem to make sense. It's common to make sense. So for example, like where I am in Denver, Colorado right now, this building, this city, big population here, they have natural gas lines that deliver the heat. And natural gas is around the equivalent of 2 to 3 cents per kilowatt hour. It is super cheap here in the United States. The power here at this building is 14 cents a kilowatt hour. And so, it's 5, 6 times higher, even with the Bitcoin rebate, however you want to frame it, the sats back, your earnings, your revenue, you can't get close to that 2 cents. And so it will cost more. And we do have two customers. We're actually converting this building, my office, and then my dentist. He is just a diehard Bitcoiner, and he wants to do it anyways. We have 20 kilowatts of solar on this building. We overbuilt on purpose to get max capacity, and that's going to make the economics work out. So if you have solar, it's already a plus. I think for a lot of the tinkerers, the Bitcoiners, the maxis that want to support the network, stack non-KYC sats, you can do it if you have cheap heating fuel, but there are some caveats that you have to be aware of. The real winners, because I agree with you, incentives drive this thing towards mass adoption, and I hope that Hashrate heating can be kind of like a Trojan horse to bring a lot of Hashrate hyper decentralize it, integrate it into homes and businesses. The real winner are people that tend to be more rural. And so they have stored heating solutions that could be liquid natural gas, liquid propane delivered in tanks. You got to shovel your driveway, fill it up a couple times a year, maybe every month. Heating oil, which is essentially diesel fuel in the New England area, these older fuel sources, these old boilers like New York, Connecticut, and things like that. There's even people that are burning wood, and wood is cheap, but it's a lot of labor to go out and get that, right? And so you can think of Bitcoin heating, Hashrate heating, as everybody should have electricity. They can be rural, but hopefully not that rural that they don't have power. And so you don't need the heating infrastructure, the natural gas lines. So propane, for example, the high altitude of Colorado, up in the mountains, the Rocky Mountains, there are a lot of people that don't live in high population towns. They didn't drill the natural gas lines through the granite. There's whole neighborhoods where you see hundreds of propane tanks in everyone's front yard. That propane is around 11 cents a kilowatt equivalent for like $1 per heat equivalent. And the power is still 13 cents. So it's only a 2 cent difference. It's very close. You count the Bitcoin rewards, you get an efficient enough miner. Maybe it's a generation old, because that's the second part of your question. And it still makes it worthwhile. And so that, I think, are the target markets: cold climates, rural, expensive heating fuel. And that can change based on the country or the municipality, the state, the city level. And the second part of your question is, I still have been, trying to answer this, is like, okay, does it only work if you're using last gen hardware? Because it is true for Bitcoin heating, we're less sensitive to bleeding edge efficiency. I don't have a break even cost because the heat is a sunk cost anyways. Rather, we're just looking to maximize our rebate. And so you get that by having a more efficient chip. You'll still get any rebate with any chip, but how do you get the optimal rebate, having the most efficient chip that balances the capex of the system, the upfront cost of a new miner versus a used miner? And I think retrofitting is a great way to go. You benefit from getting massively depreciated hardware. A big challenge with that right now, though, is the form factors keep changing. And if you're going to install a heating system, people expect their boilers or their water heaters or their furnaces to last them 30 years. And I hope we can get to a stage where that is the case, the shell, the infrastructure, but then you have these heating elements. You can think of it as a heating element, these hash boards that slide in. And you want to be able to upgrade to one 5 years down the line without having to redo the whole thing in the home or the business, and just say, oh, now a chip that's 3 times more efficient. It's been 5 years. It's worth it to upgrade, right? And breathe new life into your heating system. The flip side of that is, well, what if the ASIC chips are sold individually? What if they're directly available from the manufacturers? And we're seeing the industry shift towards that. Auradine announced it. Proto, I'm wearing their hat from Block. They're committed to this as well. And I'm still trying to answer that question in my head, which is, well, a direct to chip B2B, some other company can go and build the heaters, but is that going to be cheaper than using the last gen hardware that is reused? Maybe not. You do save a lot of time on the labor of having to desolder chips. It's kind of like the BitX model. That's how Heatbit
Mm.
is made. They're literally buying old hash boards, desoldering chips, turning it into a whole new product. It's 20 times more expensive than a $50 heater. It's $1,000. And so there are still the innovators right now, the people who want to use that, support the network, have a sweet high quality product with a nice control app to heat from home. But to get to the large scale masses, the economics definitely have to make sense. And there's a lot of work to be done.
I think the fact that, I mean, I have no idea how much it is. My guesstimate is that we have about 3 million ASICs deployed or shipped every month.
Wow.
So it's a lot, right? I know retailers from Asia that resell machines that tell me they're selling, 20,000 ASICs a month on average. And they're not the biggest elephants in the room. There's far, like Bitmain itself sells more, MicroBT sells more, so the total volume, it's possible that we're around like the to call it 2 million, whatever. Anyway, a big amount. And so for the first time now, and my listeners have heard this a bunch, we now have such a volume of used S19s, S19J Pros, and they don't, people don't know what to do with them anymore. And that fact is going to play into your hands, right? Because as time moves on, there's going to be more and more volume of these used chips. And they're, paperweights with the generations, not last generation, but the generation before that. I'm already seeing that, right? There's thousands of 40 joule ASICs sitting in warehouses, and they're starting to cost the owners money because they need the storage, right? So you're getting to a territory where the ASICs are trending towards zero, and that plays into your hands, because now if you're up in the mountains, and it's cold for a lot of time in the year, so you have high uptime, and now you can save, I don't know, 90% of your money by having an ASIC that's maybe is 3 times less efficient than like the newest and latest and greatest, or 5 times less efficient. Like the ratio just keeps moving into your favor, right?
Yes.
So I think, or my gut tells me, that it always makes sense to just go with later generation ASICs instead of slotting in a, I don't know, S21 XP anywhere for $6,000-7,000. Like that doesn't make any sense, right? Especially if you then
Perhaps
talk
we'll
about repairs
see.
and stuff like that.
Yeah, I fully agree. I do think for that to be feasible at scale, we'd like to see the hash board stop changing size. And to create a standard form factor, I imagine the larger guys want that too. They couldn't have been happy when the S19 went to the S21, but I don't know how these standards emerge, right? Like I was joking about this with a guy downstairs from Compass Mining yesterday. We were talking about the standards. We were looking at the dishwasher. You pull it out, you buy any dishwasher, it will fit into that hole. You get new tires on your car. It doesn't matter what manufacturer they fit on the rim. And so when is that coming for? Because if the large scale industrial miners standardize form factors, it inherently helps us, the retrofitters, which is interesting.
HashrateUp is sponsored by solomining.de, the place to buy open source home and solo mining devices like the BitX. With about 20 watts of usage, these solo mining devices are perfect to play the lottery from home or from the office. Get 5% off with the code HashrateUp. Thanks to the legends at solomining.de for sponsoring the content. Funnily enough, I had Colin from Giga on yesterday, and we were talking about containers, and this topic came up as well. And I just asked him, what incentive does Bitmain have to not change the form factor anymore? Everybody's going to you, right? Seal miners, MicroBT, Hydro machines, the immersions ones, I think Block as well. Orodyne is going to the typical rec space route. Bitmain brings out the newest and latest, greatest machine, Shoebox. But they are inherently incentivized with all the infrastructure out there being built for Shoebox equipment to keep building those. So at what point does it change? We don't have to get into that now. I'm just saying it's funny that you bring up the same form factor issue. Because obviously having just I'm trying to sell parts now. Tons of parts from people who build 8-bit access, and like I have all these cases and fans and control boards and PSUs piling up, and I need to get rid of them. Anyway, so we covered tier 1. I think we still have a ways to go to make sure that it makes sense from a cost perspective. And I think
Mhm.
what you said is really important, like identifying the right target markets. Um, again, here in South Africa, anywhere where people heat with electricity, that's every country or most countries in Africa, right? Where for a third of the people get cold very quickly. Funnily enough, I can say that as a German living here, when it's like okay for me, people are freezing, right? So that's also maybe a factor where people have the where demand for heat is not the same worldwide. But the uptime might only be like 30% in a year or even less, like 20, whatever. So those are the factors we need to look out for if we want to make this economic. Is there anything else we haven't covered? Oh yes, what else? Something else I wanted to ask you is how do you see sort of the capex around water heating with ASICs at home? Like all of the stuff that you need extra, the automation, the piping, the pumps, yada yada yada. How does that? How do you see that making sense at some point?
A lot of the extra capex costs right now for water heating, for example, is because of the fact that you could take a hydro miner, and there are guys that take air cooled miners or immersion specific and use an immersion tank. Regardless, you need liquid heat. You have to take that heat out of the miner loop and add it to your domestic water loop. And your domestic water supply, maybe it's hard minerals in it. You don't want to mix the two. So you don't want the water you'll consume going through the miner. Um, so you need a heat exchanger so you can pull heat from one loop, move it to the next. You need pumps, right? Well, that's just because we're retrofitting and using industrial miners that aren't designed for this. The flip side of it could be you have a hot water tank that every home has, 55 gallons here in the US and North America, and you have the ASIC actually part of this enclosure, part of the hardware itself. And so the 55-gallon water tank that looks the same as every other one is the heat exchanger. It doesn't have to be a separate
Mm.
miner that is dumping heat into a tank. The heating element can be part of it. And so the ASIC chips could be wrapped around the side of it, or a core in the middle, or something you slide in, like a protrusion sliding in. And so in that scenario, you don't need all these extra components. But to your CapEx question, those can't be built unless the real way to build them is directly from the chip level, and so we need the chip availability. And maybe the chips will become cheaper because they'll sell us last gen or binned chips that weren't up to spec for the highest efficiency that the guys that are mining as a business want. But you're right. Right now, there's a lot of auxiliary hardware required to make an industrial miner work in the home or a small business for different heating applications, for sure.
So, as we said before, moving through tier 1, 2, and 3, it becomes easier. We both agreed to apply this heating with Bitcoin mining solution in tier 2 and tier 3 versus tier 1. Why do you focus on tier 1 so much and not on tier 2, the large commercial zone, water heating again, heat consuming industrial, maybe also process heat? Um, yeah, give me maybe tell me why you don't want to focus there for now, and tell me some use cases that you are aware of for the second tier.
Okay. Yeah, it's a great question. I think I just get more excited about tier one to bring the benefits directly to the consumer, to the end user. I also think it's probably part of it is probably because I see how much innovation and overhaul, like a full rethinking of what a Bitcoin miner um, is required to bring Bitcoin mining ASIC technology into electric heating appliances that you would have at the residential scale. Um, Not to say it's boring, but it's a little bit less interesting to me to buy a 100 kilowatt rack and 10 kilowatt miners and a heat exchanger and then connect it to a giant pool. It's just not as interesting to me, but it can still save those people money. And so, to your point, like, what are some examples of tier two? Tier two is actually, I think, the sweet spot right now. I think it's the easiest, and we can get into that because the short of it is because at tier three, when you're that big, there's typically no one near you that wants that much heat. And so tier two, I think, is the easiest. I'll give an example. I just did a heat audit for a hot spring in the mountains of Colorado. And so it's natural geothermal heat, but they supplement it with propane. So it's like a resort. You can stay there, you can camp there, and there's these nice big hot pools and hot tubs. They spent $22,000 a year on propane just to supplement the heat so that the pools are 100 degrees Fahrenheit. I ran the model for him with he needs 50 kilowatts of heat from Bitcoin miners when you convert that equivalent based on the weather, the target temperature of the pool. And he's got three-phase power. That's another constraint that residential homeowners face here in the United States. We don't have three-phase power in our homes. So he has three-phase power. He can use pretty much any Bitcoin miner. And I was looking at some of the more efficient hydro miners because this is a larger scale project. You can benefit from economies of scale there. He should make $6,000 in profit heating with the Auradine hydro miner, for example. That I ran. I put that in the model. I ran 3 different hydro miners, and so he went from spending $22,000 to making $6,000 profit. That's a net of $28,000 a year,
But
which is crazy.
Tyler, why? I mean, okay, I I don't want to tell you how to do your business, of course, but I'm just thinking, dude, if you focus on tier 2 and you can help Exergy survive, you can maybe even subsidize tier 1.
Yeah,
Because the money
it's
certainly
definitely a
is
good
not
point.
in tier 1, right? The money is in tier 2 and tier 3. And if you just say to him, look, I'll build this for you. I'll build this for you at cost, and you give me 50% of the hash rate,
Yeah.
you know,
No, we're definitely going
everybody
to pursue
wins.
this project for sure. We're not going to say, yeah, now go figure it out. We're definitely going to help
That's
this guy out.
that's
It's
super
a
cool.
no-brainer for him. It's actually the best economics I've seen of any case study I've performed. So he definitely has to do it.
And did you go to the resort alone, or
So
were you
he
with
just sent
your
me his
better half?
bills. He just sent me his bills this week, but I did tell him a site visit is next. I want to go. It's a couple
Yeah, there you
hours into
go.
the mountains. Yeah, yeah,
Um, I'm struggling with this with side note, very much a side note. As soon as I sort of figured out this stranded energy and waste thing as an energy economist, I couldn't stop talking about it. And everywhere I went, I like looked through at the world with this new lens on. Um, and yeah, my better half got left behind there a little bit. So I'm wondering if you're facing the same type of issues where you run through the world with this lens on, where you see electricity being wasted, heat being wasted, that could be
yeah.
Bitcoin mining everywhere.
Yeah, I definitely do see it that way for sure. And so we're screaming from the rooftops for sure. I hear what you're saying about tier 2 as well, and we're going to perform those projects. There's also a lot of breweries and distilleries around our neighborhood as well that
Awesome.
use heat year round. So it makes perfect sense.
And they will often use electricity to produce heat, even though it would be more economic to do with something else, because they need it in their process in a specific way where it makes
Yeah.
more sense to produce it with like resistance heaters at
Hmm.
strategic places than just heating a room, with a gas heater or with a gas infrastructure type
You
model.
get so
And
much more
then
control with electric heat. Yeah.
yeah, and then if people use electricity anyway, then it always makes sense.
Yes. Yes. The cost is the same because an electric heater or a Bitcoin miner, they cost the same to run. They deliver the same amount of heat. One gives you Bitcoin, one doesn't.
Do you work on tier 3 on anything? Do you have any tier 3
I
projects?
haven't explored any tier 3 projects, no. And so where I think that might play out is larger operations that have cheap power, and you could co-locate something like a factory that uses a lot of low-grade heat, because that's another caveat. Bitcoin miners don't create, you know, industrial process grade heat where it's hot enough for certain industrial processes like steam or boiling or melting things. It's more of a low grade heat, which there is a large demand for, but no specific projects in tier 3 yet.
You talk about preheating.
Mhm.
Um, Explain preheating. And
Sure.
because I think there is something to say there, because yes, you said it's right. Of course, we're not outputting enough heat to steam water, or turn water into steam, but we are producing enough heat to preheat a heat pump or preheat something else that does it then more efficiently, right?
Yeah. So There are certain thermodynamic cycles, steam turbines, combustion processes, absorption chillers, a bunch of different things that require heat as an input, and industrial manufacturing processes as well. And
Mm.
like you said in that earlier point, they need a specific temperature and it could be different for every different business or operation. And so preheating is often something that is done because maybe there's a minimum inlet temperature, kind of like a Bitcoin miner doesn't like to have too cold of an intake temperature. There are certain industrial processes that require a minimum heat input before they can kickstart and run at their optimal efficiency. And so Bitcoin miners are great in that regard because you can bring things up to, it's still low grade heat, it's not going to boil, but it's warm enough where you can then bring it to the next step where you might get it to that boiling phase. And any of that electricity you would have spent, maybe it was a traditional resistive heater at a huge scale to preheat a process, is now performing hashing operations as well and rewarding them for doing so. Yeah.
Talk to me, Tyler, about what's happening in Finland, please.
Finland is a great example of tier three. And I want to talk to those guys that are working on those projects more closely. So they have it looks like a regular hydro industrial mining operation, but they are pulling all that heat off and sending it to, I believe, 80,000 homes in Finland. And so Finland, from my understanding, was burning a lot of wood for heat. And now they have what looks like a data center operation as far as the public opinion and perception, even if they don't understand Bitcoin. They are preheating in some cases and delivering the heat to the homes and businesses. So that works with when you have district heating. District heating is you have a centralized heat factory, so to speak, and you send that heat. And Finland is a good example of that, smaller country that has that infrastructure where the heat is actually sent to the homes, to the businesses all throughout the city. Where that might manifest in the United States is perhaps a college campus. A lot of college campuses, resorts, Disney World, things like that. They have big steam boilers or whatever it may be, a centralized heat source that is then sent. You send hot liquid, hot water over pipes to use it in radiators, use it on the tap, turn it into air heat and blow it through furnaces and et cetera, at the use source. And so district heat is a perfect example where it's large scale because a lot of people are using that heat. You're splitting it up, but it's close enough. So that was that challenge I was talking about. It's close enough to a large demand, like a city that would use that quantity where it looks like a mega mining operation, and they can actually, with high performance, send that heat so that it can be used by everyone.
Are you still selling your hard mined Bitcoin for expenses like mining hardware, electricity bills, and tax invoices? With Firefish, you can access liquidity in fiat or stablecoins without selling your Bitcoin. Firefish is a peer-to-peer marketplace for non-custodial Bitcoin-backed loans. No credit checks and no monthly payments. Sign up on Firefish today, create a loan request, deposit BTC into a multisig, get funded by an investor, and repay at the end of the term. Collateral is always at least 2x the loan. So if BTC drops by 50%, you may be liquidated. So be sure at any time to top up the collateral as needed. Thanks to the legends at Firefish for sponsoring the show. Use HashrateUp for a 30% discount on the fees and get your first Bitcoin-backed loan today. I'll add a bit of color there. So after the Russian-Ukrainian war broke out, imports from Russia became impossible, and a lot of the biomass that was imported from Russia was not an option anymore for those heating with wood and biomass, and that increased the pricing for heat, I believe, significantly. And Finland has the largest, most well built out district heating infrastructure in Europe. Right. So, and this is where I want to ask you about specific ASICs for this. Now, the struggle is, and we talked about the temperatures before, you got to get the water out of the heat pump at like 80 degrees Celsius. Oh, no, excuse me. You got to get the water out of the ASICs at 80 degrees Celsius. And that's very tough to manage because otherwise the infrastructure cannot onboard the heat for some reason. There's some technical limitations there, because you basically have various input points with heat plate exchanges and various output points with the same, right? And in Finland, it's actually the case that the price for heat that's being paid by the local energy company or whatever is public. So these companies will tell you if the outside temperature in Finland is minus X, then the revenue for heat is Y, right? So you can put that into your model. And then on top of that, you got cheap nuclear, cheap solar, cheap wind power, and a great
Right.
and a great grid demand response mechanism. So it's a trifecta for mining, really. But I don't
Yeah.
think this heating thing is talked about more.
It
Um,
should be talked about more because that makes a lot of sense. They had the infrastructure for it, they have the demand for it, they have the heating market. That is a challenge, like you said, with the 80 degrees Celsius. And I imagine that's I'd have to study it more, but I imagine, when you're sending heat over a large enough distance too, there's a loss as well. And
yeah,
because the Bitcoin miners aren't that hot to begin with, you got to make sure you can be on the upper limit there. So that by the time it reaches the end user where they want the heat, it can sufficiently keep them warm with whatever outdoor temperature it is for sure.
yeah, just like electricity, right? Over long enough distance, you've got a line loss, and
Hmm.
the electricity turns into heat on the cable.
Hmm.
So I want to talk about tier three briefly, Tyler, before we close out here. To lead into this, um, do you think that we're going to see use cases for heat move to the mines or vice versa? Because there's a couple examples in Norway again where people now ship truckloads of wet algae to a Bitcoin miner, and then that
Mm-hmm.
Bitcoin miner pumps all of their heat to dry all of those goods. What do you see happening first? Bitcoin mines being built where heat is needed, or demand for heat moving to where the Bitcoin miners are?
Probably demand for heat moving to where the Bitcoin miners are, because when it's an operation of that scale and they're still mining with high duty cycle, my gut intuition would be they still are kind of location locked based on the power, the cost of power where they are.
Mm.
And so if they can incentivize, people that are paying for heat, maybe offering them a really big discount, it's like, we'll heat and dry your things for that example, way cheaper than the other guy. We just got to truck it over here because they already have an operation that's monetizing the Bitcoin mining operation, right? It is the Bitcoin revenue. And so the heat, when that's convenient, when they can get those deals in place, is just another revenue stream for that operation. That's what I would think.
In the same fashion, Tyler, how long do you think it'll take um, before Bitcoin mining is the byproduct widely adopted in a fashion like this, where heat comes first, and we move to a world where everybody that mines Bitcoin has to make use of the heat somehow to stay economically viable?
Yeah, it's a good question. I think the bigger question is, what utility does your Bitcoin mining operation provide? If the utility is just the Bitcoin, then you better start getting creative. I think because it's ruthlessly competitive, the difficulty is always going up, the competition's going up. Um, for the guys in West Texas, where it's already hot, it's literally in the middle of nowhere. No one's going to bring things out there to get heated. What is the utility they provide? It's demand response and curtailment. And so the usefulness of that operation, you could argue. I mean, there are some months where they make more money from curtailment contracts and power purchase agreements than mining revenue, and so that utility is there a balance on the grid. They're a damper. They eat excess load. They'll shut off when it's required. That's their usefulness. The other big utility is heat, and so for anyone who's paying for heat, be it electric resistive to some other fuel source like propane, if heat is the product, then Bitcoin mining, you're all of a sudden not sensitive to hash price. You're less sensitive to all of these other whims that a traditional Bitcoin mining operation is. And part of the reason I'm excited about the residential scale too, and some of these smaller ones, is each home, each small business, maybe even some commercial and industrial ones too, manufacturing plants, they're all mine operations. But everyone that goes into work every day, everyone who wakes up in that household, they don't wake up and say, gotta run the mine, right? There's no public shareholders to keep happy. There's no marketing department to pay. There's no power purchase agreements to be on top of. It is simply a system that gets a rebate passively in the background. And so that's going to be very hard to compete with, I think. So the days of the standalone, I'm on grid, right? Um, just using Bitcoin miners to generate revenue. I think those days are not going to last forever. Another utility could be national security. I don't know what they'll all be, but it might be the case that a government says we're just going to let this be at a loss because it's in our strategic best interest to mine Bitcoin. Who knows? But I do think that heat reuse will become a large player. I think it will be the Trojan horse to bring Bitcoin mining back to some of the smaller applications. Maybe that takes more time. Maybe it is hard right now for the next 5 years. Who knows? But heat reuse is going to play a large role in hyper decentralizing mining for sure.
Sounds good. Tyler, we're out of time, unfortunately. I have a ton more questions for you. Please come back when you do the project with the hot tubs. I want to know more. Yeah. And then we can maybe talk about, the specifics, like how do you find these deals and how do you talk to the guy to make him understand it, like talk more about the sort of the business side of things. Guys, look at this book. If you want to read about Bitcoin mining heat reuse, this is your almanac. Thank you so much for your time, Tyler. Anything else you want to say? Otherwise, we close it out. Or at least tell people where to find you, I say.
Yeah, thanks for having me. It was awesome. Happy to chat about this whenever. Definitely check out the book if you're interested. Building out Exergy, so we're going to install these heating systems. If you're curious about getting Hashrate into your home or business, you can find me at my personal site, which is tylerstevens.me. I also help run The Space, which is a Denver, Colorado Bitcoin hub where I'm at right now. We do events and educational content summits. We have a Heat Punk Summit. Hopefully Jesse will come in February. It's a 150-person conference focused on all things Bitcoin heating. This building will be heated by Hashrate. And so, yeah, you can find me on there, everything I'm up to on my website. But thanks again for having me. This was awesome.
Thanks for your time, Tyler. See you next time. Cheers. Bye.